everyone, welcome back to the RobotDiva channel, where imagination meets innovation. I'm RobotDiva, and today we're all about dancing with Lilybot. But before we get into building Lilybot, let's learn a bit more about robotics. Have you ever wondered how a robot vacuum finds its way around your house? Or how robots help build cars or explore Mars? Well, buckle up, because we're diving into a world where machines can sense, think, and act. A robot is like a smart machine that can understand its surroundings and do tasks all on its own. It's not just wires and wheels, it's technology that feels almost alive. Robots come in all shapes and sizes. Some vacuum your floor, some explore space, and some, like the amazing Ameca, can talk to us and make facial expressions. There are socially assisted robots that help kids with autism, self-driving cars, drones, you name it. In robotics, the sky isn't the limit, it's just the beginning. Oh, and fun fact, the Mars rover took 7 years to build, but that cute little Roomba, around 12 to 13 years. Surprising, right? Robots aren't all created equal. Some are super simple, and others fully automated. From level 1 to 10, we measure how much thinking a robot can do on its own. But even the smartest robot still needs humans. Yep, people design, build, test, and even override robots. That's why you matter in robotics. Let's break it down. Robots are like us. They've got different body systems doing different jobs. In robotics, we call these subsystems power subsystem. This is the battery, the juice, the energy source. Control subsystem, the brain. It decides what the robot should do. Sensor subsystem, eyes, ears, and touch, all the ways a robot understands its world. Actuator subsystem, the hands and muscles. These do the moving and lifting. Motion subsystem, the wheels, the walking, the moving around town. And guess what? You can become an expert in just one of these subsystems and still be a robotics boss. But the real magic happens when you understand how all the parts work together. Now that we've seen the big picture, let's take a closer look at one of the most exciting parts of robotics, the motion subsystem. The motion subsystem is what allows a robot to move, whether that's rolling, walking, flying, or dancing. It works closely with the actuators to coordinate how the robot gets from point A to point B. Think of it like your legs and balance working together when you walk. For Lilybot, motion happens through small wheels powered by motors. When we give her a command, like move when you hear sound, her motion subsystem kicks into action. It interprets the signal and tells the motors, "Let's go." And that's exactly what we're going to do today. We're going to give Lilybot the power to move when she hears a sound. This means we'll connect 3 important ideas: sensing the sound, using a sensor to detect audio signals; deciding what to do, using code in the control subsystem to react; moving the robot, using the motion subsystem to bring Lilybot to life. Let's dive into Lilybot's motion system, see what makes her wheels spin, and then we'll show you how to code her to respond to sound. You ready? Let's build. Before we start building, tune in for the next episode for an interview with a robotics expert that can help us build Lilybot. Robotics is about more than machines. It's about you, your ideas, and your future. So hit that subscribe button, and let's keep exploring the world of tech with personality.